The FlexH2 project focuses on creating offshore wind energy and producing green hydrogen via electrolysis at an onshore site. Currently, electricity generated in an offshore wind farm is taken to a substation where the voltage is increased. Transmission in high voltage improves efficiency. The electricity is then brought ashore via cables and fed into the grid. Since the transmission is done via alternating current, AC, the wind turbines must be synchronized to the grid frequency, which they try to follow. For wind farms further away, the electricity is converted into high-voltage direct current, DC. This requires a heavy and expensive offshore substation. Onshore, the electricity is fed into the grid. Using electricity from the grid and water, an electrolyser can produce hydrogen. The FlexH2 concept is different. The wind turbines in FlexH2 can form the grid themselves and establish the voltage and frequency in the offshore network. A grid connection is not strictly needed. By making the turbines smarter, the equipment at the offshore substation can be simplified, which leads to a smaller, more efficient and more cost-competitive offshore substation. When the electricity arrives onshore, an algorithm decides to direct the electricity to either a hydrogen production facility, the grid, or both. Electricity allocation is determined by energy market prices or by possible grid integration limitations. Finally, by developing solid-state transformers for hydrogen generation, the electrical equipment in the electrolysis plant can be built with less weight, volume and materials. FlexH2 combines several innovations to provide flexibility for a more reliable, sustainable energy system, and that facilitates the production of low-cost, sustainable hydrogen.